Alright, it's Mr. Rops here, and today we're going to look at three equations and three unknowns, which is a scenario that looks something like this. And so, I always talk about the visualization at first. Well, I have three variables, three unknowns. I'm going to go to three dimensions then. And so if you can see from this, I have my XYZ axis. Here is my first plane, and that is what these graphs are. I can see the plane here. I can look that up from the top. There's the top graph. It's red. If I add on the blue one, I can see the blue graph now. And they intersect here, the blue and the red, on a line. And finally, I'm going to put the yellow graph on there. And you can see that they all intersect at a common point. And it is right there, the point, right here. And if I show it here, here's a point, -2, 0, 1. And so three planes can intersect in a point. They don't always have to, but for the ones that we're doing, they're always going to have a nice answer like this. So the visualization is three planes intersecting. I'm not even going to try to sketch this at a point. Okay, and so I can see from here, I believe the answer is -2, 0, 1. If I go to my calculator, it's going to do it for me. I'm going to go to apps, and I'm going to go to polysimultaneous 2. And then I'm going to go to simultaneous equation solver, which is number 2. But today I have three equations, and I have three unknowns. And so then I'm going to go to next by hitting graph. And I enter in the coefficients, so 3, 2, -1, 7, oh, -7, -7. I get 2, -3, 1, -3, and finally 1, 5, 5, 3. Now at this point you should pause the video and be doing this in yourself into the calculator. And once you have all the values in, make sure this actually turns out 3, because if you forget to hit enter, it remains a 0. And then I'm just going to hit solve by touching the graph button. And again, I can see that I have verified it here. So that's technology's way of doing it. We can get nice answers really quickly. But if we have to do it algebraically, we have to. What I'm going to do is I'm going to give you kind of a system just to clear the clutter away from the work we do. And so initially what I'm going to do is I'm going to try and take equations and break it down so that I have like just two variables, like x and y and an x and y, two equations, two unknowns, because that we know how to deal with. So if we take our equations here,
so taking the first two equations, let's just take those and we're going to add them up. So I have 3x plus 2y minus z equals -7, 2x minus 3y plus z equal to -3. When I add them, I get 5x minus y. The z's cancel. That was the whole point of this. I'm canceling out the z is equal to -10. And so I have an equation with just x and y. And so the next thing I need to do is I need to look at these equations again, choose a different pair. So let's choose these two pairs and eliminate the z as well. In order to do that, if I would take this equation and multiply it by a -5, then I'll be able to eliminate the z's. So if I multiply the second equation, I get -10x plus 15y minus 5z equals a positive 15. And if I just write the third equation, it's x plus 5y plus 5z equals to 3. And if I add these, I get -9x plus 20y. They cancel. That was the whole point. I cancel out the z's, and I get 18. And so now I have two equations with two unknowns, x and y, and they're the same unknowns. That's the key. You take three equations, breaking it down to two. And so this is similar to what we did last year. And if we look at our variables, I know I have a negative y and a positive 20. So let's take this equation and multiply it by 20. So 20 times 5 is 100x minus 20y is equal to negative 200. And then I have negative 9x plus 20y is equal to 18. Make sure that that's 218. I'm going to then add these equations. And again, I eliminated y. And when I see what's left, I have 91x is equal to negative, this is 182. Sorry, 182. Dividing by 91, which is a big division, but x ends up being 91, not 9x, 91. X ends up being negative 2. Once I have negative 2, then I go to either of these equations, either one. This one looks like the numbers are smaller, so I'll use that one. And so I plug in my negative 2. So I get 5 times negative 2. Subtract y is equal to negative 10. So I get negative 10 minus y is equal to negative 10. So add the y, I get negative y is equal to 0, and so y is 0. Then my final thing, I need to get z. I can choose any one of these equations, and I'm going to choose this one because for no good reason. So I have 3x is negative 2 plus 2y, which is 0, minus z is equal to negative 7, which is negative 6, plus 0 minus z is equal to negative 7. Add the 6 over, and will give me a negative 1, and so z is equal to positive 1. And so good communication then at the end says x comma y comma z is equal to negative 2, 0, 1. And so taking this idea of three equations and breaking it down into two equations with two unknowns, similar to now you're in a grade 9 question. The key is eliminating the same variable. Once you have two equations with unknowns, then you solve for both of them, and finally sub the last one back in. We will do some of these in class, but it's really good that you get a handle and good practice of it. I would like you to try this one at home before you come to class. Try it on your own, see what the mess you come up. You can check it with Poly Simultaneous.